Let's look at space travel through a erotic art glass. Relativity limits space travel and also makes it difficult for communication signals. Reviewing space travel in the quantum physics theory, the introduction of faster-than-light propulsion warp drive travel allows for faster-than-light space travel through a negative medium. Unlike Alcubierre warp drive, Kavetsky asserts a negative vacuum which assumes absorption of passive energetic energies. The idea that time dilation, attraction, and a speed limit in the space field doesn't exist. After all, it's an empty vacuum and relativity depends on planet gravity for these effects. Seemingly, that Kavetsky is correct. Communication signal can be compromised with an accelerated impulse tube-like missile of such that has the ability to travel faster than light. In such a case, impulses are released at intervals, releasing the signal as it passes through space at superluminal speed. This idea relies on Kavetsky's faster-than-light theory in quantum physics, holding that the universe is not compelled and lives in a bubble with a speed limit. The idea of bending the vacuum of space, the vacuum ducking in positive distorted energies from celestial bodies alike human aging, this signaling communication idea does not come easy but possible. Imagine no speed limit just because Aristotle, Isaac Newton, Galileo, and Einstein researched the light from the heavenly bodies to measure their perimeters. What is light but a reflection of its source? This passage presents a speculative and poetic vision of faster-than-light space travel and communication under your quantum physics theory. Here's a refined version of your concept, enhancing clarity and structure while preserving your original tone and key ideas. Through the erotic hourglass of space, a quantum physics perspective on superluminal travel. In the realm of classical relativity, space travel is constrained not only by the cosmic speed limit of light, but also by the severe lag in communication signals across interstellar distances. But through the lens of quantum physics theory, we begin to imagine an alternative universe, one not bound by these terrestrial restrictions, but shaped by an entirely different field dynamic, where Einstein's relativity hinges on gravitational warping from mass, particularly planets. Quantum physics introduces a universe where such warping is irrelevant in the vast, empty vacuum between stars. In this field, relativity's time dilation and speed limits dissolve not due to violation but due to redefinition. There is no medium to resist motion, only a negative vacuum-absorbing passive, energetic energies rather than being shaped by them. Unlike the Alcubierre drive, which contracts and expands spacetime, the Kavetsky field proposes a negative energy corridor, a space field that does not bend around mass, but rather flows as a neutral stream, unaffected by gravity. This speedway allows not just matter, but also impulses signals to exceed light speed. Imagine communication redefined, instead of electromagnetic signals delayed by distance. Superluminal impulse tubes, missile-like relays, discharge signal bursts at intervals, delivering information faster than light, a cascade of pulses riding this negative corridor. In this model, the universe is not a prison of finite speed. It is a dynamic, swelling field, an erotic hourglass ever shifting, where vacuum is a dancer, ducking and weaving with the energies of stars and aging humans alike. Our old metrics, Aristotle's orbs, Newton's gravities, Galileo's optics, Einstein's curves were shaped by light. But what is light if not a reflection of its source? In the quantum physics solution, the source is no longer light. It is the flow, the Kavetsky flow, and within it, the impossible becomes inevitable.
Space's expansion isn't passive. It creates a dynamic landscape that can be tapped into for travel or field manipulation. It redefines inertia and motion as functions of quantized space behavior. Predicts new forms of energy or motion that emerge from field alignment with expanding space. Offers theoretical propulsion systems that sidestep relativistic constraints. Quantum physics. Dark energy within the quantum physics framework, such as Rodney Kowecki's model, is a reinterpretation of the mysterious force driving the accelerated expansion of the universe. Unlike standard cosmology, which treats dark energy as a constant or scalar field, like the cosmological constant in general relativity, quantum physics offers a more structured, field-based interpretation. The quanta physics dark energy first, field-based vacuum dynamics. Dark energy is not just a passive, constant energy, it's an active, quantized field embedded in the geometry of space. It operates as a reverse vacuum pressure, pushing space-time apart by acting on quantized space units. Non-energetic propulsion potential. This vacuum field may interact with massless or low-mass particles without direct energy transfer, enabling propulsion or warp dynamics without fuel. It implies gravitational repulsion, similar to anti-gravity effects in certain field configurations. Spatial inversion and acceleration. Dark energy in quanta physics is tied to spatial inversion or stretch mechanics. Space stretches uniformly due to a built-in property of its quantized fabric. This helps explain not just expansion but acceleration as a geometric effect rather than purely energetic. Faster than light. In advanced interpretations, the dark energy field aligns along cosmic corridors, low-density channels through which faster-than-light vehicles could move with minimal resistance. Time and mass. Some quantum models propose dark energy also affects time dilation and inertial mass, modifying how objects behave across large distances or at high velocities. Comparison cosmology. Standard cosmology versus quanta physics theory is the nature of dark energy. In standard cosmology, we have the cosmological constant or scalar field. On the other hand, quanta physics theory suggests a quantized reverse vacuum field. When it comes to the energy source, in standard cosmology, it is intrinsic to space. Meanwhile, in quanta physics theory, it emerges from the space quantization structure. Its role in expansion can be seen as a passive driver of acceleration. However, it also plays an active role, driven by fields, in both expansion and propulsion. When it comes to interaction with matter, there's no direct interaction, but there's potential for geometric or field-based interaction. As for its application to propulsion, traditionally, there is none. Yet it can be used for faster-than-light drive corridors. In quanta physics theory, a ship can theoretically travel at superluminal or faster-than-light speeds without interrupting spacetime. This is because the motion does not rely on traditional acceleration through space. Instead, the framework proposes an entirely different mechanism for achieving these incredible speeds. The key mechanism here is field manipulation over locomotion. The ship rides within a modified quantized vacuum corridor, often described as a reverse vacuum field or dark energy channel, which restructures the local properties of space itself. Space-time flow alignment is another fascinating concept. Instead of pushing through space-time, the ship aligns itself with the directional flow of expanding space, kind of like surfing a wave. This clever method avoids relativistic mass increase and time dilation. Non-disruptive interaction is crucial for maintaining space-time integrity. Since the drive field is integrated with the quantized units of space, there's no tearing or breaking of space-time continuity. Instead, the vacuum field forms a topological bypass rather than an energetic thrust. To put it simply, think of it like skipping stones across the surface of a river without touching the water. Each quantized step is a real point in space, but the path cleverly avoids normal space friction and temporal resistance.
Listen carefully. We are diving into a new outlook on space theory. From Isaac Newton to Einstein to here. Thank you.
Rodney Kowecki clarification. Let's break down EQ equals a times c to the fourth in the context of quantum physics theory and what he is calling national gravity, possibly referencing Rodney Kowecki's ideas. Interpretation of EQ equals a times c to the fourth. This is not a standard physics equation, but we can analyze its possible meaning within Kowecki-style quantum physics theory. EQ equals energy of a quantum system, possibly a modified energy definition. A equals an acceleration or unknown coefficient which could be specific to a field, force, or expansion rate. And c to the fourth equals the speed of light to the fourth power. In classical physics, Einstein's equation is E equals m times c squared, which is mass-energy equivalence. C to the fourth appears in general relativity equations related to the curvature of spacetime and gravitational interactions, for example, the Einstein field equations. So EQ equals a times c to the fourth could be suggesting quantum energy is proportional to a specific acceleration or field factor times the fourth power of the speed of light. This might imply a deeper layer of energy hidden in space-time curvature, or a model where acceleration fields or repulsive forces, possibly linked to Kawecki's reverse vacuum field drive, determine energy behavior in a quantum gravitational framework. National gravity, possibly Kawecki's term, is quite intriguing. In Rodney Kawecki's speculative work, national gravity may refer to a domesticated or engineered gravity field, as part of space-time control systems. It could also be a reinterpretation of gravitational interaction within his quantum physics framework, replacing mass-based attraction with spin-based or vacuum-reactive forces. Summary interpretation. In Kawecki-style quantum physics theory, the equation EQ equals a c to the fourth power could represent a new form of quantum energy calculation rooted in space-time expansion, vacuum interaction, or repulsive gravitational forces, deviating from mass dependence and classical gravity.